Welcome everyone. Thank you for attending our Beyond Big Data webinar with Blair. My name is Jacob Barlow here at Neo4j, and I'm joined today by Amy Hodler, Senior Manager of Partner Marketing. Amy, do you want to say hello?
Hi there. Thank you everybody for joining.
We also have Nav Mathur, Senior Director of Global Solutions. Nav, you want to introduce yourself as well?
Hello everybody. Happy to do this today.
We also have Richard Sheppard here with us, the Director of Sales at Blair.
Hello everybody, good to meet you. Glad and thank you very much for joining us today.
Awesome, we're stoked to bring you today's presentation. I want to drop in a few housekeeping items before we get started. We invite you to submit any questions you have throughout the presentation using the questions box in the GoToWebinar control panel on the right side or the left side, wherever you moved it. And we'll answer as many questions as possible live at the end. Lastly, we're recording this session, so an on-demand recording will be available for you to view whenever you'd like. So again, if you'd like to participate, those questions will be in there as well. With that, I'll go ahead and hand it over to Amy to start us off.
Hi, thank you, Jacob, and thank you everybody for joining us today. We're delighted to be here and delighted to have one of our great partners, Blair Technology Solutions, as well with us. We're going to be talking about 4 different general topics, basically starting off with why graph technologies in general have been so important in these last 2 years for business, how enterprises are using native graph technologies. Nav's going to talk a little bit about some of the common reference architectures and what that looks like for Neo4j, and Richard is going to highlight IBM Power 8 plus Neo4j and how that can help you leverage your big data. So with that, let's go ahead and get started. And I first have this lovely square for you guys, a rectangle for you to look at, and basically this illustrates the way a lot of us look at our data. It's often in tabular kind of format. We think about things in columns and rows. But if you think about the nature of information itself, it's much more fluid, it's much more dynamic, and the connections are never straight lines. And if you think about the implication of that to, let's say, your business, we often look at our business processes, unfortunately, very much the way we look at our data. And so you might have hierarchies, you might be thinking about your supply chain as a linear flow, or your information as squares and blocks. But if you think about your business processes, they're always changing. You're always reimagining them. And a really rigid architecture can dictate and cause your business to be rigid as well. So you want to really be able to evolve, at the speed of whatever your business happens to be. And if you think about, again, your organization, it's not a rigid hierarchy. You've got people with unusual or multiple reporting chains. Same with your supply chain or whatever process you might be looking at. It's never a straight line. And so you really want to be able to innovate, at the speed that your business needs it to. And it's no secret that a lot of companies are challenged when they redefine their business processes to be competitive, especially today when things move, so quickly. And the pace at which data grows and the ability to connect this data is having a huge impact on a lot of organizations and a lot of industries. And if you structure things, accordingly in a flexible way, you can move quicker and take the value of and find the value of your connected data. And one of the quotes we enjoy from Gartner is this idea that graph analysis is probably the single most effective competitive differentiator for companies and organizations. And what it ultimately boils down to is a choice in technology and a choice in how you look at your data. And that's something that this echoes is basically that you do have a choice in how you look and structure your systems, your technologies, and your data, and doing so in a way that that mimics the real world just allows you to be that much more agile. And if we look at a few industries where this has actually transformed things, we can think about LinkedIn and the social graph. I mean, we've all had that experience where you realize that you've been suggested a connection to somebody that you haven't seen in years, or maybe you've never actually worked with, but they're in your chain of, your chain of the social network. Likewise, and that's done, amazing things for LinkedIn, and it is definitely the place to go for business network. And then we think about Walmart, somebody like Walmart. And that's, interesting to look at how they've remained competitive and extremely competitive in this age of, Amazon, second day, 2-day shipping and ordering. But they really look at providing real-time recommendations. And they use Neo4j to do that, looking at, what you may have viewed, what you purchased, maybe what you returned, what somebody who bought a similar product purchased, and liked or rated, and then can provide you with very personalized recommendations very quickly. And then another really interesting use case, and a way that Adidas has really transformed the way they are looking at player value. So if you think about what, let's say, say a star football player, in this case soccer, football, depending on where you're from, might be valued in regards to promotions. Adidas has actually used graphs to analyze that and to look at how well they've done, how well their merchandise does in store, online, with engagement, and then actually put a monetary value on that. So some really interesting use cases, and how these companies, some of them more digital native, some of them more brick and mortar, have really transformed themselves in the industry. So I've mentioned the term native graph a few times. So the idea of the social network and the supply chain network, probably makes a lot of sense. But why native graph, and what does that really mean? And that really looks at how people model information. So if you think about what most of us do in a boardroom, or in our lives, we go up to the whiteboard, we draw circles and lines to describe things to people, and that model is a physical model, and that's what graphs are. Is it represents with what we call nodes and relationships in a way that we would normally and very intuitively do on the whiteboard. And there's a lot of power to that because it's easier for people to understand. Relationships are apparent, and influence points, choke points, become very, very clear to people. And it's ultimately very, as I said, very easy to understand and to collaborate around, and gives you a lot of ability to kind of to move between conversations and to correlate information. So the other thing is just to take a quick moment. There we go. Sorry about that. I had trouble advancing the slide there, but take a quick moment and to explain this property graph model. So as I said, there are nodes and relationships. The nodes could be things like people, cars, product. It could be genes, whatever that might be. And, they have types and directions, and they have properties to them. So you might have the person, would have, of course, a name, where they went to school. Here we've got the Twitter handle on there. Your car has a type and a model. And so those are properties. And then if we think about relationships, those also have properties as well, and labels. So you might have, married to, or worked for, lives with in this case. And then, of course, drives and owns. So you have relationships, nodes, and properties for each one of those to describe them more. And that's basically what a property graph model looks like. So, and if we think about going back to the more tabular approach, the column and rows approach to storing data, what's interesting is if you consider traditional database like a relational data store, it's designed to store data in more of a tabular way. And so when you store your data that way, that's what you get back out. And so it retrieves data the exact same way that it's stored. And what's interesting, if you go with a graph approach to storing things, when you load the data into Neo4j, you achieve pretty much two things. First, you get all the data that you stored in the way it was actually related in that whiteboard format and that mimics reality. But there's another thing that's probably just as important, if not more important. When you retrieve when you then query the information, you retrieve adjacent relationships, which give you new insights. So the ability to see how things are related actually gives you more information. And you can do that because you'll also be able to, you can run queries that retrieve data in the way it was related, and the way it relates to the rest of the connected information, which leads you to new ways of looking at things and new insights. So another thing to think about, and that a lot of companies and enterprises don't run on just one system. So we've got relational data, we've got document stores, you've got key value stores, maybe this wide column stores as well. And it's really, and the reality is that the architecture consisting of many types of databases. And in fact, one of the biggest challenges that our enterprise customers have today is the inability to leverage these cross-silo connections. And using Neo4j, it's a very common use case for them to use Neo4j to overcome this problem. And the way that works is they ingest the data that they need to into Neo4j from all these different sources and create what's called kind of a relationship layer. And this is where you can then gain more information, ability to use the information, but also be able to do cross-silo queries and see where those connections are. So it's like a real-time product recommendations, fraud protection, things like that often use this kind of approach to connect that more disparate data. So let's take a look a little bit about Neo4j itself and who we are. So we are actually the #1 platform for connected data. We have the the highest number of users and install base out there for connected information. And that really is about us being able to power these new types of applications and analytics for people. And so as people are trying to move beyond the way they've looked at information today, they turn to Neo4j to help them with that. And so we've use cases that range from machine learning to recommendations to fraud to data governance. And actually, it's really one of the most fun things to do is to work with our customers and watch them start with one use case and then find another one and another one and another one. That's actually something that I enjoy quite a bit. So if you think about what we're trying to do and providing this native graph platform, it's really the ability to help people find that information, but also do it at a scale that they need to, and really connect workloads faster than any other database, because a lot of the world does work in real time now. And so what we've been able to do is help companies go from more of a static approach to more of a connected approach. And so if we think about what that would mean, if you think if depending on your age, you probably remember Alta Vista and when Monster was the place where you put your resume out there, or we probably still go to some of the brick and mortar banks. But what connectivity and looking at connected information is really done is really taking people more to prefer and go to the connected world. Google, using graph and PageRank, probably one of the most well-known algorithms out there, to really serve up information amazingly fast and very complete. LinkedIn we already talked about as well. If you think about Monster versus LinkedIn, there's just no comparison in today's world. And then PayPal, how often that's used now versus just even five years ago. So we really are trying to help people move into this more relationship-based way of looking information. And there's really, 3 reasons why we were able to do this. And first is, of course, as I've mentioned, the native graph platform. But we have over a decade experience in the graph space. So we're one of the first to actually develop a graph database, and then we also have a natural query language cipher that's really exceptionally easy to use. It's very human friendly. It reads like almost like a sentence. But it's not just that. The other components as well is just the ability, the mindset, the ability to think in graph. And that's something that we work a lot with our early stage customers, is to think about the information differently. And that can be, quite frankly, that can be a little difficult when you're first getting used to the idea of thinking in relationships, because we've all been trained and have so much experience thinking in that more tabular format. So that's another interesting area. And the third area that really helps us is our ecosystem. So, since our beginning, we adopted a very open source strategy, which itself has helped create a very important part of the ecosystem. So we have over 3.5 million downloads. We work with about 500 partners. And we have an amazing number of group members and trained engineers, as well as 60,000 developers and engineers that have actually participated in Neo4j training. So the power of that, I can't say enough about the power of that. We have stored procedures that are open source, that we have a huge number of contributors to just make procedures so it's easier and quicker to do very repetitive things in Neo4j. And it's really a very vibrant ecosystem. So as I said before, we're trying to help people go from a more static approach to things to a more connected approach. And what's really fun is to see this in a range of different areas. So we have native companies, digital native companies like eBay and LinkedIn, but we also have brick and mortar, like Walmart and Airbus, that have chosen to use Neo4j. So hundreds of successful deployments from Fortune 500 to, as I said, very exciting startups. It's always fun to watch that develop. And, it's really, something that, in certain industries as well that we've done, quite well in. So the retail industry, 7 of the top 10 retailers in the world use Neo4j, 12 of the top 25 financial services firms, and even in software, 8 of the top 10 software vendors as well. So we feel very grateful to have that level of trust. And I'd like to just very quickly talk a little bit about a few case studies so that you can kind of understand how people are using the product as well. And, the common, use cases, as I said, it ranges in a lot of different industries, but these are the ones that we're seeing. There's always new ones developing for real-time recommendations. We talked about Walmart already. Fraud detection, that is something very interesting. I think Nav will talk a little bit more about that in the reference architecture. But if you can imagine the being able to correlate relationships between people possibly committing fraud and being able to detect a fraud ring, and the power of that. And then network and IT operations, ensuring service assurance. So if you imagine a company that, like HP, or we have a lot of telecom providers as well that use Neo4j to help ensure that calls get from A to B the way they're supposed to be. And then, of course, master data. So understanding where all your information is, how it's connected, has a lot of implications for governance, but just as well for call centers and for being able to find information when they need. So that's an interesting use case or I should say use that spans a lot of use cases. And then graph-based search as well. So being able to search and find information that's connected to other information is then connected to 4 other pieces of information. And identity and access management. So if you can imagine the complex relationships between understanding not only does this person have the right subscription to access something that they paid for, knowing that they have access, you give them the rights to access, they're who they say they are, but they also have the right, they subscribe to one service but not another, and they get billed appropriately for that as well. So that's a very common use case, and that one's getting more interesting as IoT takes off as well, because you can imagine now you have things that have access to other things as opposed to just people and humans or corporations with access. So I'm going to quickly take a moment just to talk about a couple of these use cases. The first one that's quite interesting is actually eBay's ShopBot. If you've played with that at all yourself, their goal was really to develop a personal shopping assistant and have this kind of experience where the buyer via text, picture, or voice kind of converses and gets recommendations in a way that feels like almost talking to a friend, as opposed to a computer screen. And this is interesting because it really transformed the buyer experience, or is transforming the buyer experience, in the ability to give context into ideal purchase recommendations. And it combines artificial intelligence, natural language understanding, and using Neo4j for the knowledge graph. And to think about how you would actually look at that from a graph standpoint, if we asked the ShopBot, can you show me a brown leather Coach messenger bag, the bags under $100? There's a lot of information that actually has to be correlated to do that. And there's, the categories of color, material, brand, type of item, cost. You could even include where it's located, so how far away is it from me. There's a lot of different things that you need to correlate to do that. And a graph is ideal for that kind of dynamic and kind of rich context that's needed. So that's a really interesting case, and it's a good illustration of how graph and the relationships mimic the real world. UBS, we talked a little bit about. This was the master data, and one of the things that I really like about this use case is it really, if you think about the number of integration points, they had 400 integration points across 18 data domains. So that was a really, they had quite a bit of information they had to bring in, and they were really able to improve the level of service to customers, from IT to the actual consumers of information, reduce the risk that the data, that they had the correct data and it was appropriate, and then also simplify and get rid of a lot of redundancies as well. Telenor is a Nordic telecom that uses us for identity and access management. So when I mentioned previously the subscription, we actually have a really great use case online that describes this in detail. But basically, as I said before, trying to understand from a user standpoint, do they have the rights to look at this? Do they have the right subscription? What's the account look like? Is there a corporate element as well? So they use us for identity access management for both business and residential customers as well for their self-service portal. Marriott, we all know who Marriott is, and what I like about how Marriott is using Neo4j is it really changes the way they can do pricing. So they have some of the largest. They have the largest website, the 7th largest website on the internet, and they have about 1.5 million hotel rooms online, and they have to reprice those all the time. A very dynamic environment, and doing so slowly is not a very good customer experience, and it also costs them, in opportunity. And so we were able to, with Neo4j and the way it stores information, it's a very compact way of storing information. We were really able to help them decrease the time from just over 4 minutes to about 13 seconds in how quickly they could reprice information. And above that, also decrease their overall infrastructure cost by about 50%. And a lot of that has to do with the efficiency of storing related information in a graph format. So you don't have to have as much complication overhead, and it stores very compactly and computes very rapidly. And so they were able to reduce their overhead in the pricing systems. So with that, I want to quickly talk a little bit about the product itself, and then I'll turn it over to Nav after that. And just, we have a lot of information online, but just, kind of at a high level, we are an enterprise-grade native graph database, and as I said, it allows you to store and access data and relationships in a very compact, quick manner. You can traverse any level of depth, and when I talk about traversing, that's moving from, when we talked about the people and the cars and the nodes, moving from person to person to person to car to person to bag to color, whatever that might be. And then add and connect new data on the fly. So one of the interesting things about Neo4j is that it allows you to update information very easily without having to worry about schema changes, taking your database down so you can add 4 more categories, changing all your query logic because you've now added in new areas. So it's a very nice way to, in a very dynamic environment, which quite frankly seems to be the norm now, to be able to make changes. And so it's really designed from the start to help people ensure performance. The ACID transactions, I think I've got a little information on that later to talk about the importance of vetted and guaranteed information. And then also just as I talked about earlier, much easier way to look at information, to draw it on the whiteboard, and that has a big impact on developers and solutions teams, and just allowing them to move quicker from whiteboard to code. So I've talked a little bit about native and how fast we can query, and I want to just spend a moment to just talk about why that is. And so if we think about how information is typically stored in different formats and often sharded over multiple machines, when you have to run a query, you really have to go from node to node, then make a join to some other information, possibly on a different machine, then come back with the related information that you're looking for. So the hops can actually take quite a bit of time. And if you're using Neo4j, it's completely in memory and it's unified. So the queries are much quicker, and you're just always one hop away from the next item. And so that really, this index, what we call index-free adjacency, and that basically means that you're, if you think about a bunch of linked lists, you're always just one hop away from the next item. And so you don't have to go look at an index somewhere and come back, which can really slow things down. So when we talk about performance, we often talk about the number of hops and the degree of complexity. So in most relational and other NoSQL database types, you really do get this, this nonlinear scale of response time. So you slow down quite a bit when you start moving to multiple machines and multiple joins. And we notice this quite significantly at about 3 hops. So you're just doing a couple hops, just a couple connected items. I just want to know what a brown leather bag. That's 3 items. Yeah, not too bad. You can do that with some decent performance. But once you start moving into those other areas, when it's not just a brown leather bag, it's a brown leather coach bag, you start seeing these dips quite significantly in performance, and response time increases quite a bit. What's really interesting about Neo4j is that you have a near linear scale as the hops and the complexity go forward. So as that increases, and so if you have a complex query type of environment, you really have to have a native graph database, to scale for that. And we have had customers that have gone from minutes to milliseconds in their performance, and we've seen, and I believe that was the Marriott example, but we have seen significant drops, the customers moving, especially doing highly complex queries, in going to Neo4j. And so if we think, okay, so what does fast really mean? We've got some sample data. This is actually a small data set comparison just to kind of illustrate the differences. But you can see if you're just, even if you're just counting the nodes, you're going from over 200 seconds, in a non-native graph database, and then with Neo4j, we were under a millisecond. PageRank there at the bottom is really interesting for those that are doing analysis that need to understand, the importance of significant nodes in a network, kind of what PageRank helps do. Here's an example where you were on like 2,500 or so seconds down to 27 seconds. So really quite significant speed ups, especially when you're doing more complex or even just trying to correlate 3 or more, bits of information. So I mentioned ACID earlier, and one of the things about, the kind of guarantees that you need for your information, you never want to lose or corrupt your relationships or the data itself, of course. So it's very important that things are atomic, that you have consistency, you're isolated, that you're durable, all of those things that ACID mean. And what Neo4j does is it allows you to have atomic causal consistency. And so as the graph transactions move together as if they were one ACID transaction with some built-in safety as well, so that every step of the way we maintain and persist the relationships. That's actually really difficult to do in most anything that's non-native. And so with non-atomic and a non-native graph, you get an eventual consistency. And so what that means is without this ability to persist, an ACID graph transitions, you're eventually consistent with the information, but that also means that there's possibilities and propensity to lose, corrupt, or miss relationships, especially if you're polling at particular times. You may not have the most accurate or up-to-date information. So we support a number of different platforms. We've got, across the board, what you might expect from, Windows to Linux and IBM Power Linux, Solaris, HPUX, and then cloud platforms as well, and containers. So we actually have Neo4j you can install, online with AWS, Microsoft Azure, or use Docker, to have a container as well. So thinking about Neo4j and the fact that it's really built for an enterprise, I've talked a lot about native graph, but also the, making things as accessible and practical as possible for, for your developers and the people querying information, making it user-friendly from the model standpoint all the way to the tools. And then also just having, integrations with other popular, environments and languages as well. And then this very expressive. So one of the things that I think a lot about when I think about Neo4j is a very connections first approach. So we always maintain, persist, and ensure connections. And there's this bit of democratization of graph as well, because the approach that we take is very much focused on making things accessible, easy to use, and easy to maintain as well. So with that, I'd like to turn it over to Nav to talk a little bit about solution architecture, and I believe he has a couple examples for us.
Great, thanks, Amy. So what I'll do today is, talk about two sample problem statements around cybersecurity and fraud, and then talk about a common architecture approach to solution these problems, so that you have some context in terms of the solution architecture that I will describe. So if you go to the next slide, this is something that has been put together by MITRE. MITRE is a non-profit organization, a very large non-profit that has been set up by the government. Really, it provides the government with lot of the innovation and solutions for the most critical challenges facing the country around defense, intelligence, aviation, healthcare, cybersecurity, and so forth. So this is sort of the premier organization that is looking ahead on behalf of the government and solving some of the most critical challenges. So MITRE uses Neo4j, and they built something called as a SciGraph. And if you just to kind of contextualize this, for cybersecurity, most organizations, large organizations, they have a network operations center where they have, a large pane of glass, which is, where they have, dashboards from multiple different sources, whether these would be endpoint management software or log management or other services that they're trying to manage and monitor. So all these monitoring points and their dashboards are basically visible on a single pane of glass. That's been sort of the traditional approach to do network monitoring, cybersecurity monitoring, and so forth. But there's a lot of human element involved in then sort of correlating things happening on one dashboard versus another, even though it's on a single pane of glass. So the more modern approach is really to start correlating these things through software and technology, and since it involves multiple connections, a graph is basically the right technology for doing this. So what MITRE did was they essentially took their entire network, all the way from firewalls, routers, databases, systems, applications, all of these things, and correlated them through a graph. What has connectivity to which component, all of those things they modeled as a graph. Not only that, they then modeled typical threats and typical actors, typical incidents, the typical tactics, techniques, and procedures that hackers use also as a graph, and they then also modeled mission dependencies. So what that means is that they not only model the network and the systems, but then what are the critical processes that they're trying to protect? What is the overall from an enterprise standpoint, what are the critical services that you're trying to then protect? So there's a connection between the processes and the services. They modeled that as well. So now when you have an attack progressing, you can kind of see that, hey, they've attacked this firewall, or they've attacked this network component, or this particular database, and what does that mean to me? What critical services are going to be impacted by that, or where is this attacker going with this coordinated attack? What does it point to? So those are type of things that you can start now assessing in advance. So you're staying ahead of the attacker in terms of what they're planning, because a lot of times the attack emanates from a different area. Then they kind of do some reconnaissance, they do some infiltration, and they sort of maneuver themselves to get to the eventual target. But before they do that, if you can figure it out by virtue of this connected graph, then you're going to be ahead and you can shut them down, or at least protect the assets that you're trying to, the services that are most critical to your organization. So, you can very easily then start to analyze how an alert over here is related to alert over there, and what they're trying to go after. What is the shortest path to the target that they could possibly take, and so a lot of this visualization can happen using Neo4j. And we have a lot of different customers in this cybersecurity area. It's one of the most prominent areas for us. And so the next use case, if you go to the next slide, is talking about credit card fraud. And if you think of any credit card issuer, or this would be applicable to them. So essentially, you have a card issuer, you have that is issuing cards to a card holder, the people like you and me, and we make these transactions at merchants. But what happens is this card gets skimmed, either at an ATM skimming, operation, or at the terminal that has been compromised, or there's data breaches, as we all know, happen all the time. We've seen in the news lately with Equifax and Yahoo and whatnot. So essentially, somehow through these breaches or skimming, the fraudster gets hold of this credit card, and what they do, a common approach is they do what is known as credit card testing in fraud parlance. And what that involves is they're increasingly testing the card for increasingly larger amounts. So they might go to a Starbucks and buy a cup of coffee for $2 to check whether the card works, and then they will go and buy something for $5 and $10. And what that proves to them is this card does not have any alarms associated with it. And even if they do get caught, it's not a big deal because very, very small amount. So they are testing this card at this stage. Once they've gone through this testing 3 or 4 times, and then they make that big purchase of buying a computer or buying some jewelry or something like that, that is what you really, as a credit card company, are trying to stop. So this is a pattern of increasing amounts and testing at different locations, and some of these locations as well are the credit card companies are pretty familiar with what those would be potentially. So they can build a pattern with this, and they can look at these patterns through a graph database, and then essentially catch or prevent that big purchase from happening. So how do we solution this? If you go to the next slide, this is talking about all of these transactions coming in. You usually come into a relational database, and then you have lots of other data points that you can correlate with it. So you might have, merchant data, you might have third-party data, and so forth. So all of this, typically, a data science team today is working on to do discrete analysis. That means, they're just looking at individual databases and trying to see if there is some element of fraud going on there. But it's very hard to catch that on a discrete basis. But when you start connecting this information between the transactions, between the merchant data, between the credit score data, and all of those things, and start putting it in a data lake, you start finding those patterns. Typically, the data science team does. And so if you also then correlate it back to the cybersecurity example, you can have a lot of data coming in from different endpoint security management software. In this case, I have sort of shown sort of an IBM stack and log management from Splunk. And you have all of those transactions coming in. You have the virus signatures, you have known vulnerabilities, all of that. And again, you're finding patterns based on all of this information. So once you find a particular pattern, you then load the relevant data into Neo4j. And this is where Neo4j is very powerful in running through sort of your entire data set to find all instances of this pattern. And not only that, because you can now start to visualize this pattern within Neo4j, the data scientists can then actually fine-tune the pattern. They can easily remove the false positives, and then you start. If you just go forward, Amy, you can start then the actual transactions, streaming them directly to Neo4j, and Neo4j can start sensing these patterns. And then as soon as it establishes that pattern, whether it's that credit card testing pattern, or if it's the cybersecurity threat pattern that you've defined, it can respond back in real time to prevent that fraud from happening, that prevent that big transaction from going through, or it can kick off a process to alert somebody or something, and so it's very powerful in that sense, where it is looking at hundreds of pieces of connected information in real time to establish that pattern and respond within milliseconds to prevent fraud, to prevent that cybersecurity threat. So this is what an overall sort of solution architecture looks like. And then if you go to the next slide, I have sort of taken this and also integrated it with IBM Watson from a cognitive pattern recognition perspective. So data science teams can also leverage automation and cognitive pattern recognition that IBM offers in this area. Also, this is extremely powerful in increasing the effectiveness of data science teams. You can actually, we've heard quotes from multiple customers that it was taking us months once we found an actual pattern. Our data science team found this pattern within a data lake to actually operationalize that pattern. So what Neo4j can do is really integrate the data science team and what it's doing with the actual operationalization of that pattern, in real time, right? So that's very powerful. Because and then if you look at the overall solution, you can start to do things like impact analysis. You can start to do variance analysis, and really through rules and complex event procedures, you can analyze your situation through a graph much easier. And visualization is a key aspect of that analysis, being able to do decisioning based on these complex rules, and then anomaly detection as well. So it's a complete solution for these type of use cases. And it's basically integrating a bunch of data silos together through a graph to provide all of these services, if you will. So next is going to be Richard talking about Neo4j on IBM Power 8.
Well, Nav, thank you very much, and hello everybody. Once again, thank you for investing some time with Neo4j and Blair today. What I'd like to do is take a few minutes just to talk a little bit about the hardware and the platform that you may run this on. And so for those that don't know us, Blair has been an IBM trusted partner for over 21 years, and our goal in life today is all about enabling businesses to improve business insight with their data. And as you've just heard from Nav and from Amy, I mean, we're talking about data and relationships. And if you're like me, relationships are kind of complicated. Today in the business world, data and business and relationships with customers and products and services, it's all getting really, really complicated. And because it's complicated, you have to have a lot of power to work that complication out if you want to try to gain some sort of insight, some sort of business insight to that. And so as we go to the next slide, what I'd like to talk to you a little bit about is if you're going to do this, which we believe there are great opportunities to do this in a business world, you need good hardware to run this. And what I'd like to talk a little bit about is how IBM is utilizing their Power platform to help design and give you the best performance possible. And so IBM Power is really that hardware platform that is focused and can be optimized on Linux. Neo4j being the open environment here. The Linux environment is something that we need to take advantage of. Power systems from IBM are optimized for Linux. And if they are optimized for Linux, this gives us greater ability to provide better processing and storing of that in memory. So when we look at some comparisons, we're looking at something where maybe Intel is only focused on a much wider basis. IBM Power takes that ability to focus and optimize on Linux and enables us to get greater threads per core in terms of parallel processing. You get 4 times memory and bandwidth to enable us to speed things up. And of course, 4 times more cache to help lower the latency. Our whole presentation today has been about performance. It's been about optimizing. It's been about real time. And the reality is if you're running data-centric workloads to help your business gain insights to be better with your clients, you need to do it faster and you need to do it efficiently. And the IBM Power system is that platform that we would recommend people to consider as they look at graph databases to help their business insight. As we go to the next environment, one of the key aspects of IBM Power is that it is part of this open ecosystem. The Open Power Foundation from IBM has over 300 members associated with this. 30 hardware and technology providers. I mean, you've got partners such as Google and Rackspace that are taking advantage and running their complicated logarithms and great databases on Power systems to provide good customer service and fast solutions for them. And clearly, most importantly, why is open the best? It's all about embracing the wisdom of the crowd. And I love that statement as I talk to my peers at IBM. You're getting the opportunity when you work with IBM Power that you can take the wisdom that multiple people have, and it helps IBM innovate their technology and their hardware platforms so that people can collaborate and they can look at new ways to drive new solutions for clients. At the end of the day, this open power environment really enables developers to really rule the environment, rule the stack, and make sure things are ready for optimization. And really, we want to make sure that there's less time building and testing and more time developing. And I think that's what the message clearly is with the IBM Power system. But you know, sometimes you got to talk a little bit about practical uses. So when it comes to hardware, we wanted to just talk a little bit about a practical solution in the next slide that we looked at. And it's just taking a little bit of a simple example. Power 8 is CAPI-enabled acceleration. Here we are showing an example of running Neo4j on a system, 20 cores, 128 gig memory. It's a Linux-driven system versus an Intel-based comparable system. You know, we've said that this is all about performance, but with performance, you want to make sure that you get the best price performance and the best cost as associated with it. And so what we can see is that in this simple example, when you're running operations like a Neo4j database, you're really getting the cost of operations, you're getting 1.61% times better price performance, so that the cost of every operation is less running it with an IBM Power system. And so you're getting also 1.82 performance on those systems. So clearly the focus is on performance, and the bottom line here is that you're able to get that with an IBM Power system as you consider this and run those business impacting workloads. So in general, just in conclusion, I just wanted to mention a little bit that this is a complicated puzzle. as you go forward, we're here together, both Neo4j, Blair Technology Solutions in partnership with IBM, suggesting to you that there are great things about running this type of application and database on Power systems. You're going to get that performance, as Power can provide 56 terabytes of extended space. So one of the great advantages of Power in a performance perspective. You're going to get the services from us if you consider looking at some samples here. You're going to get the insight, those 64,000 people that Neo4j can draw upon. You're going to get the insight of IBM and the open Power system, and you're going to get our thought leadership from a Blair technology perspective. You're going to get the third piece of the puzzle in any kind of business case scenario is around total cost of ownership. You need to find the business value and the financial value in doing this. It's not simple. You have to pull it all together, and you have to find return on investment, or you have to find a way to generate more revenues. And then finally, as you take advantage of this and you look at the power of working with Power Systems and Neo4j, you're going to be able to optimize the outcomes. And so the piece comes together, and as you do that, you're going to find more and more examples of where you can apply a graph database within your businesses, and then you'll see the value, and it'll keep snowballing further as you go forward. So we pull together our organizations with one big, lots of different puzzle pieces, but we come together as one that gives you maximum business outcomes. And so just in closing, from my perspective, I just wanted to mention that Blair has been part of the IBM ecosystem for 21 years. We focus on the value of data as an asset, as you can hear Neo4j does as well. We're certified on designing and configuring and working your IBM Power systems and considering it. And today, just a little bit of a commercial, we'd really like to have you talk further to us about how you might adopt a graph database to help with your business needs. And so as we close, there are opportunities for us to do a graph workshop. Let's look at some of your business challenges and how we might turn those into a graph relational environment to get some insight and faster decisions so that you can improve your business. So appreciate you taking some time, and thank you, and I'll turn it back to Amy.
All right, great. Thank you, Richard. Thank you, Nav. Really appreciate your insights here. There's a couple things we can do if you're interested in hearing more. And actually, we had one question come in about getting started, so that's perfect for this. There's a couple different things we can do. You can register for a brown bag graph talk. There's a URL here. It's just simply neo4j.com/brown bag, and that will get to the three of us will understand, tell us a little bit about what you're looking for. We can sit down with your team and just talk about whether you have a situation that calls for a graph, and if so, what that might look like. You can also attend Graph Connect. So we have Graph Connect coming up in New York at the end of October, and there's a discount code that you can use via our joint friends and partners at IBM. IBM CD50 is for a 50% off code, and that event has the largest gathering of graph enthusiasts and customers and people interested in just understanding graph in general. We have over 40 speakers at that event, and we also have training as well. So if you have technical teams that want to come the day before, there's also some technical training. And the URL for that is graphconnect.com, so pretty simple to get to. There's also a couple opportunities with both Blair and Neo4j. If you are interested, as Richard mentioned, if you're interested in considering a proof of concept or a clinic on site, we also have offerings for that as well. So with that, I want to thank everybody for joining. Jacob, were there any other questions that came in?
I don't see any other questions here. You're welcome to drop them in there. If I don't see any here, thank you everyone for joining. Awesome presentation. We will email the recording of the presentation and the slides to the email you used to register for this webinar. Let's see. I don't see any other questions coming in here. So yeah, we'll send them out.
All right.
And thanks again for joining everyone, and have a great day.
Thank you all.
Thank you. Bye.
Thank you.